Hi everyone, welcome to revision session of week 1 to week 4 machine learning foundations. I would like to check, am I audible?
Yes, sir, you are audible.
Okay, so we can have two approaches. Either I ask all of you for your doubts, or we can go ahead with week-wise revision. So what should we do?
Is good.
Week-wise, sir.
The week wise is better.
Okay. Then we can start, right? Or shall we wait?
Yes, sir, we can start.
Okay. So let's start with week 1. So it forms the basic fundamental building blocks of machine learning, which will be used in upcoming courses in general and machine learning applications. As you move ahead in your careers, you will be using all these things knowingly, intentionally or unintentionally. So let's start with week 1. Okay, so so I will be taking care of those topics which are important for end-term exam. So don't worry about it, Pralay. We'll be covering those. Let's cover it one by one. So for week 1, first of all, machine learning is introduced. So machine learning is nothing but the process of making a computer learn from experience. So experience is nothing but data, the data that we feed. So what is the difference between traditional programming and machine learning approach? In traditional programming, we have rules in our hand. Okay, so mathematical rules we know. So it's easy. Week-wise weightage for NTOM, Vedakattu, I am not so sure about it. But what I can say is those weeks which are already covered in previous quizzes have lesser weightage in general. And those weeks which are new have more weightage. Okay, so it is there on Discord, so you may check. Okay, so anything else?
No, sir. Please continue.
Okay, so what happens in traditional programming approach? We have some set rules. So what we do, we have input, then we apply rules on it and we get output. That is how it operates. Okay, and in case of machine learning, what happens? We feed in input, output, and rules are created as output. So this is what happens in case of machine learning. Now, next very important thing is machine learning should be, and in real life applications, it is used only when traditional programming fails. So you should not try to use machine learning if it is not required. So this is also sometimes happen. People are so much biased towards machine learning that they try to use machine learning if it is not required. So that should be avoided. Next thing is no data, no ML. So if you do not have data, you cannot perform machine learning. You cannot build models and you cannot hence have predictions. Okay, so this is again a part of machine learning, very important thing to remember. Some applications are spam detection, then weather prediction, recommendation systems in Amazon, Flipkart, and all. So these are the basic things covered in machine learning part of week 1. The next is data. So data is nothing but the information that we obtain from different sources. For instance, you get data from your online streaming, you get data when you fill a form, when you do a survey. All these are the potential data sources from which you get information. Okay, so technically speaking, what is data? Data is nothing but collection of vectors. So where each vector forms a record, and when you stack those records over one over another, you form the whole data set. So that is what is data. So every data set has some attributes. So by attribute, I mean characteristics. For example, if you collect data about a person, an employee in an organization, what can be his characteristics? It can be employee ID, then his age, then his educational qualification, then his salary, then how many years of experiences he has. All these things form the attribute of that particular record. So attribute is nothing but the characteristic of the person, right? Or that particular instance that you are saying as attribute, and these are stored usually in columns. So when we are saying attributes, columns, features, characteristics, they mean one and the same thing. Okay. Next thing is row or record. So what happens? Every row in a data set is a particular instance of that data set. Instance means if you see a row, you will find a particular employee with all his attributes. Okay, so this should be clear. So when you want to represent this data, it is usually in the form of M cross N matrix, where M is the number of records and N is the number of attributes. Okay, so this part is again, I think should be clear by now. You have already completed machine learning foundation. So any doubt in this till now?
No, sir.
No, sir.
Okay. Next thing is model. So what is model? Model is nothing but abstraction of reality. So real life processes are very, very different from what we see. For instance, if you have seen the ideal gas equation in your class 12 physics, so we say PV equal to nRT. This is the ideal gas equation, but is it a real equation? No, it's an ideal gas equation because there is no ideal gas, so you cannot say this is a real equation. Fine. So what you are actually doing, you are assuming that the gas that we have is an ideal gas, then you get into a equation because it makes things explainable. So this is what is the work of model. So model, what actually model does, it simplifies reality. It may not be actually giving you reality, but it simplifies reality to a great extent. So your analysis becomes a way easier. Okay, so that thing you should keep in mind. So model is not exactly reality, it is a simplification of reality. Now different kinds of models are there. Majorly two classes are discussed in the week 1 lectures, which are predictive model and probabilistic model. So what is a predictive model? Now suppose I have data instances or I have data records for previous 6 months, and I want to calculate whether there will be rain today or not. So that is a kind of predictive model where you are predicting something. Now it can be of two types, regression and classification. When your target output is continuous or real number, you say it is a regression problem, or your prediction is a continuous number or real number, you say it is a regression problem. And if your output is belongs to classes 1, 2, 3, for instance, whether India will win or not, now it can have 3 possible cases: win, lose, tie, or maybe match gets abandoned. So 4 possible classes. So number of classes are fixed. So such such particular cases come under classification. Next type of model is probabilistic model, where you actually do not predict something, but you find likelihood. What is the probability of a person being in Mumbai on this particular date is a probabilistic model. Or what is the probability of Rishi Sunak winning UK presidential elections or prime minister election? That is again a probabilistic model. Fine, where your output is probability, not a particular number or class. That you call probabilistic model. So I will stop maybe, and I want to know if there is any doubt, anything that you want to ask.
No, sir. Clear.
Clear, right?
Yes,
So
sir.
we can move ahead.
Yes, sir.
Next thing is learning. So what is actually learning? Learning is the process in which data is converted to model. Okay, so model is formed using data. Now there can be two kinds of learning: supervised learning and unsupervised learning. The name itself says it all. Supervised learning means your data set has target variables, the real values of target variables. For instance, suppose I want to predict how much score Virat Kohli score in his next innings. Now I have his runs scored in previous whatever matches he has played, maybe 350 matches he has played. So I have 350 innings mein how much scored he has done in every inning. So by using that, I can predict what will be his score in next in. So this kind of learning is called supervised learning, where I have something to train. Such a method is called supervised learning. Now there can be another type of learning which is unsupervised, where what you do not have a value for target variable. So here the main purpose is to find the structure or attribute in a given data set without knowing anything about it. So basically unsupervised learning is used for performing exploratory data analysis in a given data set. For instance, sir has covered dimensionality reduction, density estimation. These two are covered by sir in week 1. There can be other things. For instance, topic modeling. So in topic modeling, what you do, you feed your model with a lot of documents. Now what your model does, your model tries to find out in which particular class this particular document is there. For instance, this particular document belongs to sports, or it belongs to international relations, or it belongs to adventure, or it belongs to entertainment. This is the work of this learning algorithm. So such things are called unsupervised, where you have no target variables, real value or actual values. Okay. So any doubt in this, supervised, unsupervised?
No, sir.
No, sir.
So there is another class called semi-supervised, where what happens, we have some part of the data which has target variable and some other part which doesn't have target variable. So such a process is called semi-supervised. So as you go learning further or explore more machine learning, you will get into semi-supervised learning. Next thing is loss function. So what is a loss function? So whenever you are seeing, you are forming a model, now model gives some output. Now how close that particular prediction which model gives is to the actual target values is measured by loss function. Okay, yeah, Surtanik, the learning happens after getting the model or after we get the model, learning happens. Okay, so to answer this, Surtanik, machine learning is an ongoing process. Initially what happens, you have a data set, you divide it into training, test and validation sets. Now you train a model, that model gives you a prediction, loss is calculated. If loss is acceptable, you go ahead with the model, or otherwise the process is repeated. So iterations take place. So learning take place when you start forming the model, or when you are using the model, or even when you say this model is good, the learning continues. Every time you feed data, so what happens in real life cases, we go on fine tuning the model. For instance, suppose you make a Amazon account. First day you do a shopping. Now, next time when you go and search something, you will get some recommendation. So when you created your account based on your profile, some model was formed. Now, when you purchase something, that data is used to refine the model. Now, what happens next? When you have already brought, now they will do market basket analysis. So he has bought this. Now he will be taking 2-3 more products like this. So model gets even more refined. Now, suppose you buy 2-3 items. Now they will predict more. What should be the recommendation next? So this way your model goes on becoming better every time you input a data to it. Okay, so it's an ongoing process, and no model is perfect by the way. Every model has to become perfect after it gets data. So more data, more better the model will become. Okay, I think I was clear, Shrutanik. Yeah, so reinforcement learning. I don't know, maybe Yugendra, if I'm taking your name correctly. So reinforcement learning, what happens? You see what happens in case of reinforcement learning. You reward the given model. For instance, you are playing a game of chess. Okay. Now what happens? Suppose you are playing with computer at basic level, basic chess. Now you can beat computer, right? So what happens when the computer loses the game? It is stored in memory. Okay, and that particular data set will say to the computer that you did mistake here. So your model is trained on the basis of the mistake computer has done. So it is reinforcement of the mistake. Okay, now what happens? Suppose you play basic level game and your computer wins. This is also stored in computer. So this way you won. So your reward is also getting reinforced. So this is what happens in reinforcement learning. You reward learning from mistakes. Yeah, learning from mistakes or learning from even success. Both you can say. Learning from mistake is like reinforcing the mistake, and learning from success is like reinforcing the reward. So this is what is reinforcement learning, and it is a lot of research is going behind it. Okay, so any more doubt? You can feel free to unmute and speak. So what happens when I go into chat, it is creating some kind of delay. Okay.
Sir, I think you can go ahead.
Okay.
Sir,
Next.
sorry,
Yeah,
sorry to interrupt. Just one question. Like, will we be doing any problems also as part of this practice regarding like dimensionality reduction and all of that?
I think you already have solved problems, right?
Okay, and I just want to know, in this session, will we be doing
No, so we have 4 weeks to cover, right? So I could not come up with any problems. So we
Okay.
have 2 hours and 4 weeks.
Okay,
So I'm
okay.
trying to be very fast. And for problems, I can say if you solve your this graded and practice questions of
Yeah.
week 1, that should be sufficient.
Okay. Okay, sir. Thank you, sir.
Okay. At most, the wordings will change. You will get questions of similar kind.
Okay, sir. Thank you so much.
Sir, this follows for entire week 1 to 4.
I can say for week 1. Rest I am not sure, but for week 1, if you say, see, there are a lot of definitions and understandings where I think questions, very few questions can be found. And numericals are like standard. You have standard error questions or you have loss questions. Those can only be asked, right? For dimensionality reduction, there is a loss formula. For I think other also methods, there is some standard formula that you are going to use. Misclassification rate, all those things. That is there in week 1. So that forms a numerical base. And anyway, this philosophy part is very easy to grasp, right? So there is no special problems on it. Am I clear?
Yes,
Yes,
sir.
sir.
Okay. So loss function, I think we were clear with it. And this loss function questions, numericals on loss function is very important. So go through week 1 loss function wale questions. That will be very useful for you in end term. Okay. Next is data. Now, when we have total data, suppose I have 100 records in a data set having 5 columns or 5 attributes. What I do, I take 80 of those and form a training set on which I build a model. Now, what happens? I take rest 20 and form a testing set, whether the model that I built is actually a good model or not. That I am going to do on test set. Apart from these, there is a set of data points which is called validation set. Now, validation set is an optional set. So if you are using a method where cross validation is taking place, you need not have validation set in the model. But if you are not using any cross validation set, then what you do, you take 80% into training. Out of that training, you take another set in as validation. So what validation does? Now, suppose from the training set, you have built 5 models. Validation set will validate out of all these 5 models, which model I should select. That is the work of validation set. So it selects the model. Okay. So any doubt in this? Any doubt in this split?
No, sir.
No, sir.
Okay. So let's move ahead. So week 1 has this much of things only. So for numericals, I would say loss function numericals and some numericals from the practice and graded assignment. That should be sufficient for your final exam.
Okay, sir.
So in week 2, we have these particular topics: continuity, differentiability, linear approximation, higher order approximation, multivariate linear approximation, and directional derivatives. Okay. So I think from your basic mathematical knowledge, you know continuity. So mathematically, how we define continuity? Suppose the value of a function is equal to value of the function when it is approached from right side and value of the function when it is approached to left side, having very close values. I have to take a call, please bear with me. Yeah, I'm really sorry for the interruption. So basically what continuity means, when you are approaching a point from left side and right side, and you have functions value at that particular point, and all these three are equal. So we say that particular function is continuous at that point. Okay. So physically speaking, suppose you have a function fx and you are drawing it, and you can draw it without lifting your pen. Okay, so we say that particular function is continuous in that given range. Okay, next thing, whenever you are calculating continuity, one thing that you should keep in mind is first to see the definition of function. If your function definition fails, then there is no point of checking continuity. For instance, there was a question on which there was debate last time. Suppose I have a function x square minus 1 divided by x minus 1. Okay, and I want to check at x equal to 1 whether the function is continuous or not. Fine. Now, some people say that x square minus 1 can be divided into x plus 1 into x minus 1, then x minus 1 gets cancelled, numerator, denominator. That way of doing continuity is wrong. Why? Because when you have a function whose denominator is x minus 1 and you are putting x equal to 1, then the definition itself fails. That particular function is not defined at x equal to 1. So you should not check, first check the definition of the function, then go for continuity. If definition is wrong itself, then no point of checking continuity. Okay, so function is not defined there.
So why can't we cancel the denominator and numerator?
Hello? Yeah?
Why can't we cancel the denominator and
So
numerator?
you cannot cancel it because it will be 0 by 0 form. So what is the 0 by 0 form?
But the graph of the function will be same as x plus one.
No. If you draw the graph, it will be whole at that point. It is not continuous because 0 by 0 is indeterminate.
Okay.
It is undefined. So if something is undefined, it cannot be continuous. Okay.
Sir, but we don't change the function. The function remains
You are
same.
changing the function. When you are doing x square minus 1 divided by x minus 1 and you are just striking off x minus 1 from both sides, you are changing the function. How can you say you are not changing the function?
Sir, in some sense, we're just trying to get it into the lowest form.
You are changing the function, no? If you are striking off denominator and numerator, you are changing the function. It was x square minus 1 divided by x minus 1. It was not x plus 1. There is some significance of x square minus 1 divided by x minus 1 and x plus 1. These two are different functions. Varna, you can directly give x plus 1, no? Why to give x square minus 1 divided by x minus 1?
So, but in Desmos, when we plot, we are getting the same.
In Desmos, you zoom it.
But sir, in other way, we are able to cancel out this x minus 1 from the numerator and denominator because at x not equal to 1.
At x not equal to 1, you can strike it off. But
Yes,
x
we are
x
able
equal
to.
1, you cannot.
Yes, you are able to
and,
cancel out from the numerator and denominator because the x not equal to 1. That is,
And the learner who said Desmos, no, just plot it on Desmos and just zoom out.
Yes, sir. It's coming one comma undefined.
Undefined, yeah. So that is how it is. So x plus 1 and x square minus 1 divided by x minus 1 are different functions. So mathematically, technically they are different. Otherwise, I can directly give no fx equal to x plus 1. What is the point of giving x square minus 1 divided by x minus 1? I want to show that this physical process should not be defined at x equal to 1. Therefore, I am giving it like that. Okay. Am I clear?
Yes, sir.
Yes.
Yeah. Next thing is differentiability. Again, suppose a function is continuous. First criteria is continuous at A. Now, suppose you find this tangent from both sides. And if these two are equal, then we say the function is differentiable. And its value is given by f dash A. Okay. So basically, you calculate these two right terms. You see that these are from right and left equal. You call it f dash A. So this is the definition of differentiability. Okay, this is first principle of calculus. If I'm not wrong, in 11th, 12th class, we have studied it. And so first criteria is a function should be continuous at A. Then only you can check differentiability at A. And if these two limits are equal, fx minus fa divided by x minus a as x approaches a minus, and fx minus fa divided by x minus a as x approaches a plus, then we say it is differentiable at A having value f dash A. Okay. Next thing is linear approximation. So linear approximation is nothing but tweaking this particular differentiation equation, you get this formula for linear approximation. So what you are basically doing, if you solve this particular equation f dash A, what will happen? F dash A into x minus a is equal to fx minus fa. Then you take fx equal to fa plus f dash a x minus a. So from this particular formula, you get this particular equation Lx equal to f plus f dash a x minus a. So in a way, you are saying for this particular function, only the first derivative is of importance. Okay. And no other derivative is of that much importance or contributing to that particular function. Therefore, you are saying by only taking first derivative, I am able to explain this particular function. So therefore, it is called linear approximation. Okay. So you can very well find an analogy of this equation Lx equal to fa plus f dash a x minus a with straight line equation. So straight line equation, if you want to find slope, how you find slope? Y2 minus y1 divided by x2 minus x1. So instead of y2 put y, instead of x2 put x. So y minus y1 equal to m x minus x1. So from this, you are getting y equal to y1 plus m x minus x1, which is the equation of straight line, which is same as the linear approximation with certain replacements, like if you put x1 equal to a, y1 equal to fa, and m equal to f dash a. So that way you are going to find the equation of linear approximation. Any doubt in this?
No, sir.
No, sir.
No, sir.
Next, higher order approximation. So what I am saying, in linear approximation, I was saying only the first order derivative was sufficient to give me value of the function at that particular point. Now I am saying first order approximation is not sufficient. So I want to go for higher order approximation. So I go for second order, I go for third order, and then I use Taylor series. So this particular equation, if you see, Lx equal to fa f dash a x minus a f double dash a by 2x minus a whole square. This is nothing but, this particular equation is nothing but Taylor series. If you know Taylor series, so Taylor series gives me higher order approximation. Okay, Taylor series, if you people know, right? Most
Yes,
of
sir.
us.
Yes, sir.
Yes, sir.
So if you know, yeah. Any doubt? Anyone was saying something?
No, sir. Clear.
Okay, so from Taylor series, you can get higher order approximation. So this is for two case square assumption. So we say it quadratic. For third, we will call it cubic, and so on and so forth. So for higher order, we use this particular Taylor series. So actually, this 2 is nothing but 2 factorial. Similarly, 3 factorial, 4 factorial, and so on and so forth. If you go and see Taylor series, it will be clear. Next, multivariate linear approximation. So till now, when we were studying and higher order approximation, what we were doing, we were taking only one variable into consideration. Now, suppose I have two variables, x and y. Then I go for multivariate linear approximation. So the linear, what we do, first we will find out derivative of function with respect to x, partial derivative of function with respect to x at AB. Then I will find partial derivative of x, f. Okay, first we will find partial derivative of f with respect to x on AB. Then we will find partial derivative of f with respect to y at AB. Then I will multiply fx, which is nothing but partial derivative of f with respect to x, multiply it with x minus a. Similarly, when I am finding y, I will do it. I will multiply it with y minus b, and then add all these with function value at AB. This will give me linear approximation of function at particular point AB. Okay, so again, this is similar to linear approximation formula. What you have to do when you are finding the derivative with respect to x, you have to do x minus a. So when you are finding linear approximation with respect to x, okay. So what you have to do, you have to multiply it with x minus a. And similarly, when you are doing it for y, so you have to do like this. And for y, what will happen? You will do correct. So this way you can remember. Now you have to add this with function value at a comma b. Okay, so this way you get the linear approximation.
The y minus b, right?
Yeah, sorry, y minus b. Correct. Thank you for correcting. It is y minus b. Okay. Next, any doubt in this?
No, sir.
No, sir.
Yeah. So again, for week 2 end-term exam, this linear approximation, higher order approximation, numericals are of importance. Go through it once from practice and graded questions. It should be sufficient. Next is directional derivative. This is one of the most important parts of week 2. So what we do in directional derivative is nothing but rate of change of the function. If we allow all the variables in x to change simultaneously in some particular direction, which is given in the question or which is given in the situation. Now, suppose I have a function which has which is a multivariate function having two variables x and y. Yeah.
So very sorry to interrupt. Could you just repeat that statement again about directional derivative? Which
Yeah.
you just...
So what happens? Suppose I have a function f. Okay. And it is dependent on suppose three variables x, y, z. And suppose I want to see how the function changes when I am allowing x, y, z, all three to change simultaneously in a given direction. I call it directional derivative.
Okay.
Got it, right?
So all three x, y, z are changing simultaneously in a given direction.
Yes. Right. Yeah, correct. Yeah, I will share. Who was this? I will share Dhiman. Okay. So what I'm saying, I have function having x, y, z dependency, and I am seeing f is changing with respect to x. Similarly, f is changing with respect to y, and f is changing with respect to z. Okay, and I am seeing effect in u direction. Then I will say fu is directional derivative. Ignore the spelling mistakes. Okay, derivative in u direction. Got it? So this is what is a directional derivative. So there is a function which has dependency on variables. You change all three variables and see what is the effect in a given direction u. Then you say it is a directional derivative in that particular direction. Now how to calculate that mathematically? So what you do, you simply take the components of the direction given. Okay. How will you take components of direction given? Suppose I want to find, I have suppose a function f equal to x plus y plus z. Okay, I want to see in direction I plus j plus k. Okay, I have to find directional derivative. So what I have to do first? First, I will find fx. Okay, whose value will be 1 in this case, right?
Yes, sir.
Correct, right? Fx is nothing but derivative, partial derivative of f with respect to x.
X
Yes, yes.
Similarly, fy will be equal to
1
1 and fz will be equal to
1.
1. Correct? Now what I will do? I will simply take a dot product of 1 comma 1 comma 1 with what?
U.
U, right? Not
Yes.
U.
U,
Normalized
sir.
U.
Yeah.
Normalized U.
Okay.
Unit U. Okay, so what you will do? You will take dot U divided by
No.
norm of U. So it will be 1 comma 1 comma 1 dot 1 comma 1 comma 1 divided by what should be the length? It is square root of 3. Okay, so it should be something. What should be the dot product? It is 3, right? 3 divided by square root of 3. This is how you solve directional derivative problems. Got it?
Yes, sir.
Any doubt in this?
Yes,
Yeah.
sir.
Can you discuss
Yes.
the maximum direction, the direction in which it decreases and increases?
Yeah, before that, yeah, hello.
Yeah, go ahead.
Yeah, before that, I'm not getting how this came, like a square root of 3 means u is 1 I plus j plus k.
Yeah.
So how this u upon norm of u is 1 comma 1 comma 1
So,
upon square root of 3. I'm not getting.
yeah, okay. I explain this. So see, what I am saying, if you see the definition here, directional derivative of fxy is rate of change of f if we allow both x and y. So in our case, it is x, y, and z. Okay, that is clear. To change simultaneously in some direction u, right?
Yeah.
Now, when I am saying direction, it means magnitude 1. Okay. Are you getting me? When I am saying in some direction u, it means I am only considering the direction of u, not the magnitude of u.
Okay.
So when I am taking this only this part, let me show you. Only this part, I have both magnitude and direction.
Hmm.
Okay, but when I am dividing it with norm of u,
Hmm.
I am just cutting off the magnitude. Basically, magnitude remains same and direction is added.
Yeah, that I got. But
So
the value of u upon norm of u,
huh?
how is it going to be 1 upon square root of 3? Only this
This
part.
is just finding unit vector. If I am saying find unit vector in the direction of I plus j plus k, what it will be?
Okay, there are 1. Okay. Okay. Got it.
Correct, right?
Yeah, you should be means 1. Yeah. It's unit vector. Yeah.
Correct, right?
Yeah.
Any
Yeah.
doubt?
Sure.
Any further doubt?
No. Thank you.
Anyone else? Now this is confusing. Many people get confused here.
Yes, sir.
So I can move forward, right? Or any other doubt?
No.
Yeah,
sir.
sure,
No,
sir.
sir. No, sir.
Yes, sir, move forward.
Okay. So I am moving ahead, right? Okay. So okay, week 3 I have not covered here. Week 3. Okay. Now week 3 contains these following topics, which are 4 fundamental subspaces, orthogonal vectors and spaces, projections, least squares, and projection. Okay, can you give me a minute? I have to take a break for water.
Yes, sure, sir.
Yes, sir.
Yeah, thanks a lot. Yeah, I'm back. So the contents of week 3 are 4 fundamental subspaces, orthogonal vectors and subspaces, projections, least squares and projection onto a subspace, and some example of least square.
Sir, sorry to interrupt. Just one thing before going to week 3.
Yeah.
In week 2, with keeping the n term in mind, the higher order approximation and like linear approximation and multivariate basically, and directional derivatives. These 3 are important numerical based questions, right?
Oh, yeah, it's on mute. So linear approximation, the higher approximation, directional derivative. Linear approximation, derivative important, higher order important in numericals. So I think
Sorry, sir, you are
continuity differentiability. Hello, am I audible?
yeah, now
You were breaking up before.
Okay, now am I audible clearly?
yes, sir.
Yes, sir. Yes.
Yeah, so I was saying, so this linear approximation, then higher order, and then directional derivative. And these 4 are important for numerical purpose. Continuity and differentiability, I don't think any numerical will be asked on this.
Okay.
Or if it will be asked, so it will be very easy.
Yes.
I mean, that can be solved intuitively. So out of these, even linear approximation is most important, and directional derivative.
Okay, sir.
Okay. Multivariate is nothing but what to say, a transformation of linear approximation. That's it, right? If
Yes.
you remember this particular formula, this is nothing. You directly remember this. And directional derivative is we solved one question, right? So like that only it will come.
Yes, sir. Okay.
Okay.
And
Thank
sir, how to compute that direction in which it increases or decreases maximum or something?
So that is your grade, right? Grad. You have heard of it? Grad.
Yes, sir.
है ना? So
हाँ.
if you find del f, you get direction of maximum or minimum. So minus del f is the direction of minimum and del f is the direction of maximum. So how you calculate del f? Del f is nothing but this partial derivative.
Hello.
Hello?
Hi.
Am I hearing some noise or?
No, sir. I think he can say.
Okay. So any other, no doubt, right? No further doubt?
No, sir.
Okay. Now, so for week 3, my screen is visible, right? Week 3 is on your screens or not?
Yes,
Yes,
sir.
sir. Yes, sir. We can see it.
Okay. So for week 3, we have these particular topics covered, and we will follow all these one by one. So 4 fundamental subspaces are basically you have these particular 4 subspaces: column space, row space, null space, and left null space. Okay. Now, what is a column space? So if you see all these columns, A11 through AM1, A12 through AM2, and so on and so forth, the space which is formed by all the columns, space formed by columns of A is nothing but column space. Okay. Similarly, space formed by columns, rows of A are called row space. Similarly, what is null space? Null space is nothing where this particular Ax equal to 0 holds good. So all those X forms, all X for which Ax equal to 0 form null space of A.
Sir,
Yeah.
sir, how the column space is subspace of R to the dimension M, as
Yeah.
there are only M columns, so I am confused.
Okay. Column space is a subspace of Rm. This is because, okay. Now see, what is the length of each column? Now, a column is defined like this, right? Column is defined like this. Am I
Yes, sir.
audible? Yeah.
Yes,
So
sir.
every column can have M entries, right?
Yes, sir.
And therefore, column space is subset of Rm. Okay.
Okay.
This is because the length of column is M. You can simply say length of column is M. Similar argument goes for this subspace of Rn. Okay. And similar argument goes for all other spaces. Similarly, if you find null space of A transpose, it forms left null space of A. Okay. So basically column space of A row space of A, null space of A, left null space of A. All these are four fundamental subspaces. Column space of A is nothing but the subspace formed by all the columns of A. Row space of A is nothing but subspace formed by the rows of A. Null space of A is nothing but all those vectors X for which Ax becomes null or zero, that is null space. And if you take A transpose and find its null space, it is nothing but left null space. Next, orthogonal vectors and subspaces. So how do you define orthogonal vectors? So if what?
Here, null space is subspace of R power n, right? N, why?
Null space is subspace of R to the power n. Okay, this is because A is M cross n, right? Correct. And X, what should be its length? Some n cross 1, right? To multiply. Right.
Yes.
Yes, sir.
Therefore, it's similar to this argument. The length of all this X, the length is n. Therefore, it is a subspace of R to the n. Correct?
Yes, sir. Yes, sir.
Got it right?
Yes, sir. Understood.
Okay. Next, what I was saying, orthogonal vectors. So if two vectors are perpendicular, okay, that is angle between them is 90 degree or 270 degree. We call them orthogonal. Now, if you remove this term vector and place space, you will call it orthogonal space. Okay. Yeah. Okay. So Tallam and Dhiman. Tallam has shared, I think, some link where important slides are uploaded. So you may go and check over there. Okay. So basically orthogonal vectors are those where the angle between them is 90 or 270 degree. Okay. So when there are two vectors whose angle between them is 90 or 270, the dot product will be 0. Or if I am saying in terms of matrix, so what happens if I am saying x dot y, it is nothing but x transpose y or y transpose x. Okay. So these are also 0. So then I am saying a particular given vector is orthogonal. Next, very important thing is rank nullity theorem. So rank is what? When you are reducing a given vector into its echelon form. So whatever are the number of non-zero rows is called rank of given matrix. Dimension of reduced echelon form of a given matrix gives rank. Now, if you add rank with nullity, so what is nullity? Nullity is nothing but the dimension of null space of a given matrix. That should be equal to the number of rows. So this is nothing but rank nullity theorem. Similarly, if you find dimension of left null space and dimension of row space and add them, it should give me number of rows. So this is how, columns. Okay, please explain orthogonal with respect to transpose. Abhishek, can you be clear? Can you unmute yourself and ask question? Hello, Abhishek.
Sir, can you please state the rank nullity theorem just once again, sir?
Yeah, I will state that, but someone has texted me before you. So I will come to your question. So someone had question. Please explain orthogonal with respect to transpose. So I am not getting what exactly he means. Abhishek? Okay, AI, can the big picture be elaborated? So what do you mean by big picture?
That is
AI?
given in the slide, the big picture. I think he's referring to that.
Okay. Okay, this big picture, this is a picture taken from your this book,
Sir, your
linear
voice
algebra
is
book.
breaking.
Is it clear now? Hello?
Yeah, now it's clear.
Now it's clear. So there is a constraint with respect to internet. So this big picture slide is taken from, I think, this standard book. I don't remember its name now, linear algebra book. So there they have mentioned maybe the big picture. So basically what it is saying that if you say see row space and null space, it will be perpendicular, and column space and left null space, it will be perpendicular. I don't know what is the meaning of big picture. For a okay, Abhishek, for a orthogonal vector A transpose X equal to 0, how it came? Okay, so I'll explain this using an example. Now, suppose I have two vectors. Yeah, Abhishek, okay, your mic is not working. I got it. So I will explain you. Now, suppose I have two vectors, 1, 0, 1, and 0. Yeah, correct. Sandeepan Naik. It is a linear algebra by Gilbert-Stein. 0, 1, 0. Okay. Now, suppose I call this vector as X. Vector as I want to find a dot product. So X dot Y. X dot Y will be what? 0 plus 0 plus 0, correct? Which is equal to 0. Now, now suppose I take X transpose. So it will be what? 1, 0, 1. Correct? And if I take X transpose Y, it will be equal to 1, 0, 1, and multiplied with 0, 1, 0. You will again get 0. Okay, this is what I mean when I'm saying X transpose Y equal to 0. So dot product is nothing but taking X transpose Y as a matrix. So I think I was clear, Abhishek. Okay, so it is clear. Now there was some question from a girl. I'm not remembering name. Hello.
Yeah, I think she's saying to revise the rank and dimension.
Yeah, rank nullity, right?
Yeah.
So now suppose I have a matrix 1, 1, 2, and 4 and 1, 1, 1. And I want to find its rank. Its rank will be equal to 2. Can you tell me why? Any one of you?
One is a multiple.
It has
of
two
other.
pivots.
It's a
This is because if when I am
Dependent, not
reducing it to echelon form, what will happen? 1, 1, 2 and 2, 2, 4 are dependent rows. They will cancel. These two will cancel each other, right? So one of them will remain. Therefore, this matrix has rank 2. Now you find its null space. I think calculating null space you people know, right? By now, you can calculate null space?
Converted
Yes, sir.
to echelon.
Yes. So go ahead and calculate null space. You will find the dimension of null space will be equal to 1. Now, suppose you see this. If you add these rank and nullity, this is nothing but nullity. This is called nullity. You will get 2 plus 1 equal to 3, which is nothing but number of rows. So this is what we mean by rank nullity theorem. Okay. So I think the person who asked this question, it is clear, right?
So, sir, rank is number of independent rows and nullity is number of dependent rows, right?
Nullity is the dimension of null space. If you find null space and find its dimension, that is nullity.
Okay.
Okay, you know how to find null space, right?
Yes, sir.
Yeah, so find null space and then find its dimension. That is nullity. So basically, when you add rank and nullity, you get number of rows. This is what we call rank nullity theorem. Any doubt in this? Any further?
No, sir.
Okay.
one doubt, but not
Yeah.
exactly related to this. So when we are given vectors, do we write them column wise or row wise?
We write them column wise. So see, mathematically, there is no actually meaning of writing column or row wise. This is just a convention which is getting followed from long time. Traditional convention.
Sir, but one vector has, let's say, for example, we have a data set, and in our data set, one column is one vector.
Okay.
And so each and every row in that particular column constitutes to a similar set of scale. But if we write it row wise, the scale will
Similar
be
set of scale, I don't understand.
let's say, for example, we have two columns, sir. Column A, column B. Column A is the height, column B is the weight.
Okay, so are you on your laptop or computer?
Yes, sir.
Yeah, so I'm allowing you to share your screen if you can write on whiteboard or something.
Sir, I am connected through my phone, but
okay. Go ahead. Yeah.
So I was just saying, let's say we have two columns in a basic spreadsheet. One is height and one is weight.
Okay.
And if we write all the values below the height column, they have the scale is of related to meters or centimeters, whatever. And weight would be in kilograms or grams or whatever. So now if we take the vector column wise, it will be different from taking a vector row wise.
Okay.
So that's my question. Like, do we consider a vector column wise or row wise?
Okay. Because I have two parts to this question. Answer is of two parts. Okay. Now suppose You are interested in heights of all the person in our class. Okay. So there you will take your vector column wise. Okay. Now suppose you are interested in weights of all the person in a class. You will take vectors in column wise. But now suppose there is a person named Ram in your class. Okay. And I want to find both his height and weight. How will you take that vector?
Row wise.
Row wise. So that depends on situation you are taking into account.
Okay. Got it, sir. Thank you.
Got it, right? But in general, what you are saying, when we are saying in this particular case, when we are taking all heights, so they are of same dimension. Therefore, we say this is a single vector of same type. Similarly, weight. That particular column has all similar records. So we say all the dimensions are same. So that is how we go about it. But when we want to have a heterogeneous record, it will be row wise. It will not be column wise.
Got it, sir. Thank you.
Okay.
So one thing, that 2 plus 1 is equal to 3. Is it number of rows or it should be number of columns, I believe, right?
Rank nullity M cross N. Okay,
Yeah.
column.
What becomes
Got it.
number of columns?
Yeah, thank you.
Thanks.
Okay, next thing is projections. So any further doubt in this rank nullity and previous parts, orthogonal, fundamental spaces and all these things?
Clear, sir.
Okay, next is projection. So basically what is projection?
Sir, I have a doubt.
Yeah, go ahead.
Sir, rank is non-zero rows in reduced row echelon form of a matrix.
Correct.
Am I right, sir?
Yeah, you are right.
Okay, thank you, sir.
Okay, this was your doubt? Yeah, you are right. Next is projections. So projection is basically, see, now suppose I have a vector A and this particular vector B is there. Now I want to see how much or what particular part of B is towards A. So I take a projection P of B, which is in direction of A. This is what we call projection. So basically finding projection is nothing but finding shadow of a given vector in direction of another vector. Okay, now I can give you a very good example. When if suppose in class 12th you people may have taken physics. So in physics what you were doing, 40 kilometer per hour in northeast. Now suppose I have this situation. So how do you find out x and y component? This is my velocity. I hope most of you are from science background, or if you have not been, so you may be knowing velocity and direction stuffs.
Sir, x will be 40 cos 45 and y will be 40 sin 45.
Yeah, okay. So how you were finding it out?
Well, we know this.
40 cos 45. Can you tell me why cos 45? Why not sin 45?
It's a projection component.
Yeah, projectional component of what?
Of
So
the
you
vector.
people know triangle, right?
Yeah.
So if I am saying there is a triangle like this, here is angle 45. This is V, this is Y, and this is X. Then cos, I'm having trouble writing this. So I say cos 45 equal to what?
X by V.
X by V.
X by V, correct? So basically V was equal to then sorry, x was equal to this v cos 40 cos 45, correct? So this was nothing but dividing this v or projecting this v in the direction of x. So this is how you used to find projection. So it is no different. It is same. Finding this projection is similar to finding this x component and y component. It's just that now you are doing it in terms of matrices. Okay. Am I clear?
Yes, sir.
Yes, sir.
Okay. Okay. Second way of looking into it is, now I have v and x. Now suppose I want to find dot product of v and x. Okay, so I will increase the font. How do you do this? I don't know. Okay, like this.
Thank you, sir. Thanks. This is better now.
Okay. So now suppose I am giving you another situation. I want to find dot product of v and x. So what is the dot product of v and x? It is nothing but length of v, let me call it v, length of x, let me call it x, cos 45.
Yes, sir.
Correct, right?
Yes, sir.
Okay. Now suppose from this I want to calculate x. So what will be x? X will be nothing but v dot x divided by v cos 45. So this particular formula in matrix form is this. Is this. Okay. Are you getting me?
Yes, sir.
Okay. So this way, whatever we have learned already in physics is getting replicated here. It's just in matrix form. So what you are basically doing, you are basically taking dot product of A and B, then dividing it with the length of A and then multiply it in the direction of A. This is what you are doing to find the projection. Vy should be sine 45. Where? Yeah, okay, yeah, correct. You are right. Vy should be sine 45. Correct. Thank you, Ravina. So in the flow, I wrote it cos 45. It should be sine 45. Any doubt in projection anymore? So numericals, I think you people can very well do now, because projection matrix you already know how to calculate. Then projection matrix into vector will give me projection. This you people have already done in enough numericals. I just wanted to give you insight. So you have already done this. It is nothing new. That I wanted to tell you. Okay. Next is least square approximation. So least square approximation is used when we have too many equations to solve. Okay, so there we go with least square approximation. So now I suppose I want to calculate 3 variables. I have equations. In that case, what happens? I have more data than required. So in those cases, what happens? The column spans a large dimensions. Okay, so this particular line. So what happens in that case? I get a result which is, now suppose I have many data. I have fit a model like this. Okay, now what is least square basically? corresponding to this point, this is the actual point, I have a prediction here. Similarly, corresponding to this particular point, I have a prediction here. So when I subtract y predicted, I get an error equal to y p minus ya, where yp is y predicted and y is y actual. This is my error. Okay. And when I have suppose 10 terms, so for all 10 terms, I add E1 square plus E2 square plus so on and so forth plus E10 square. This is my this is called squared error. Okay. Now, so this particular model will be accurate when this particular error is small, right? So that particular line for which square error is minimum is called least square line. Oh yeah, sorry, star 2 or raised to 2. So in Python, when you program, no, I think you write star 2. So that has come here. Yeah, star 2, correct.
Double star.
So star generally refers to multiplication, right? It is raised to 2.
Yes, sir. Yes, sir.
Okay. So this is what we call least square solution. Okay, now let's move to some problems. So I think fundamental subspaces you people have solved many times by now, right? No need to go to it.
Yes.
Projections also, I think, yeah. Yeah, go ahead. Someone had some doubt.
Can you show the before question? Yes, sir. This one.
Yeah, so we some doubt.
So can you just give a short?
Yeah, like it's
Okay.
a theory one, just you can little
Okay,
bit.
okay. So what happens? Suppose I have given a matrix A. Okay, and I want to calculate all the fundamental subspaces. So for column space, what you do? For column space, you simply reduce it to row echelon form. Okay. Now, see, when you reduce it to row echelon form, finally 1, 2, -1, 0, 0, 0, and 0, 0, 0 is left. So this particular row forms the column space. This particular. How you get it? See, first you R2 minus 2R1. Okay.
So first we have to transpose the matrix, right?
For row space.
Yeah, okay. No, 1, 2, -1 is the column span.
Okay, okay, sorry. My bad. So for column space, you simply find the pivots. Okay, and you take the original column. So now this is a matrix A. You reduce it to echelon form. Okay. Am I clear what I'm saying? Hello?
Yes, sir. Yes, sir. Yes, sir.
Yes. So what you need to do, you need to reduce it to echelon form. Now, for your non-zero pivot, wherever there is non-zero pivot, you go to the original matrix and take that particular column. So in this case, when you reduce it, let me write, what will be there? 1, 4, you do this, R2 minus 2, R1, and R3 plus R1. So what you will get? You will get 1, 4, 2, and 0, 0, 0, and 0, 0, 0. Okay, this you will get. So there is only one pivot. This, right? Now for this particular pivot, you go to the original matrix. And the pivot corresponding to that original matrix is your span of column space. Got it? Hello? Am I clear?
Yes, sir. Yes, sir. Clear.
Clear, right?
Yes.
Now, what to do for row space? For row space, just transpose the matrix. Now, if you transpose the matrix, it will be 1, 2, -1, and
So for row space,
4.
it's just a row after reduced row echelon form, right? 1, 4, 2.
Yeah, that is also correct. That is also a right method. That is not wrong. Or you can do this. That is also a right method. There is nothing wrong with that. This method is also okay. Now what you need to do, you have transposed the matrix. Now follow these particular steps, which I have already done. So what will happen? Now you do this. R2 minus 4 R1 and R3 minus R3 minus 2 R1. Okay. Now you will that you are left with 1, 2, -1, 0, 0, 0, and 0, 0, 0. Now again go to the pivot with corresponding element. So from that you will find out here again your pivot is this. So go to the original matrix. Go to the original matrix with this pivot. So this is the first column, 1, 4, 2. So you find out span like this. Clear?
Yes. Yes, sir.
Yes, sir.
Okay. For null space, what you do, you find x equal to 0, right? Okay. So for null space, what you do, you take the reduced form. Where is it? Where we calculated? Yeah, here. 1, 4, 2, 0, 0, 0, enter 0, 0, 0, and multiply it with x1 x2 x3. Now when you find out this x1 x2 x3, you will get your span like this. Okay. You can solve it, right?
Yes, sir.
Similarly, for left null space, what you have to do, take this particular reduced matrix and perform the same steps. Okay.
Excuse me, sir.
Yes.
So during the for null space, when we solve the homogeneous equations, we solve for u and then for v.
We solve for u and then for v means?
I mean, first we solve for one set of equations, like for during the.
So see, I'll solve it for you maybe. So here, what is the equation you are coming with? You are left with x1 plus 4x2 plus 2x3, correct? That is equal to 0, right?
Yes.
Yeah. So now suppose I write x1 equal to minus, I am taking to other side, minus 4x2 minus 2x3. Okay. Now suppose I take x3 equal to 0. Okay, take x3 equal to 0 and x2 equal to 1. Then what is x1? x1 is -4.
-4.
Right? So from this come to this particular first band, -4, 1.
So how we assume
Basically, you have to vary
x3, how we assume that x3 should be 0 and x2 should be 1?
Okay, so you don't assume. There is another method. This is the easier method, therefore I go with it. Otherwise, there is another method. Now you take x2 equal to s, x3 equal to t. Then you find out in that term x1 equal to what it is, -4s plus minus 2t. Now form a matrix according to that. How will you form that? Matrix will be -4s minus 2t. x2's value will be what was s2? What we assumed x2, s. Okay, s, and x3's value will be t. Now divide it into two matrices. It will be -4, 1, 0, whole into s plus
-2, 0, 1.
-2, 0, 1. T. Got it? Now this is also a method. Go with whatever method you like.
Okay, sir.
So in the previous the one which you would solve first, taking x3 0 and x2 1, it's basically the independent columns. You're basically like the non-pivot columns, the independent ones, x3 and x2. You're assigning two values, 0 and 1, because they're the easiest. Then you're finding the other one. That's
correct. This is purely by intuition.
Okay, but you chose x2 and x3 because they are the independent variables.
Correct.
Okay.
Because they were not non-pivot elements.
Non-pivot, yeah. Okay, sir, thank you.
Yeah, that is the method to go about. So this method, again, both methods are whatever is convenient and whatever is logical to you, go with that. Both are correct. Okay. Any doubt in this? Yes.
A span means all the vector means x, y, z is orthogonal to each other, right?
Yeah. Sorry, I could not listen to you.
This span means this 3 -4 1 0. This, if I take this as a x, y, z, this x, y, z.
Sorry, you are not audible. You are very feeble. Am I having this problem, or all of you are having this?
Hello.
There is some disturbance.
There is some disturbance.
Can you hear me now?
Yeah, go ahead.
And this span means this x, y, z is orthogonal to each other, right?
Orthogonal? No, not necessarily. Independent.
No, independent, but this 3 is perpendicular to each other, right?
No. Independence and orthogonality are different concepts. See, when two vectors are orthogonal, they are independent, but vice versa is not true. This is a very important objective question. Independent and orthogonality are not vice versa true. Orthogonality always means independence, but independence doesn't always means orthogonality. Orthogonal and orthogonal and orthonormal. See, when we have two vectors which are orthogonal, they are called orthogonal. Okay.
Sir, not able to hear you.
Please repeat.
Hello.
Yes, your audio is a bit broken.
We are losing our audio intermittently, sir.
Okay, so there is some connectivity issue. Is it fine now?
Okay, sir.
Yeah,
Yes,
now
sir.
it's clear.
It is good.
Yeah. Okay.
About
So I was saying orthonormal is when there are two vectors which are orthogonal having magnitude 1. That is orthonormal. Pralay had this question, and this part is clear, right? Someone was asking me about these should be orthogonal, these span wale vectors. No, not necessarily. They should be independent, not orthogonal. Okay. Next, I think projection matrix and all these questions you have already solved enough. No need to go through it, right?
Yeah, no. You go.
Okay, least square, I think also you people may have solved for quiz 1 and quiz 2. We have we also had a revision session where we solved all this. Any doubt? If you have doubt, I can go ahead. Otherwise, we'll skip.
Can you explain this a bit?
Which one? Least square?
Yes, sir, least square.
Yeah. So in least square, what happens? Basically, you have to solve this A transpose A x hat equal to A transpose B. Okay. Now, what you do for A, whatever is the matrix A, you pad it with another column 1. Now, suppose you are keeping that column 1, 1, 1 on right side. Then your order of slope and intercept will be as shown in the figure. But if you keep 1 on the left side, that is the first column, then this slope and intercept will interchange. That's it. Otherwise, everything remains same. So I will maybe show.
Which one will change?
Yeah, I'll add a text for your understanding. Now suppose I have a matrix A. Okay, let me give an example only. I have two variables, X and Y, and the values are 0, 2, 3, and 3, 4. Okay, now suppose I want to fit this model. Then I suppose want to fit this model. Where should I move it? I should move it here. Okay. So my matrix A is equal to what? Take all the x's, right? First 0.
Sir, sorry to interrupt. Could you just mention like what will be the question type for which we are solving this? In the sense, like what will be the structure?
It will be like fit a model, fit a least square model of the form y equal to mx plus c. This will be some question of this type. Okay.
Okay, sir.
Maybe the wordings may be different. Don't go with the wordings, huh?
Yes, sir. Yes, sir. I just wanted to know the okay.
Don't go with these wordings. Wordings can be tough, but the form remains same. Okay. So what you need to do, first you have to form the feature matrix. So feature matrix is nothing but whatever is the independent variable. So here the independent variable is X. Just stack the independent variables together, then put additional dummy column having all value 1. Okay. Y will be equal to your target variables. So 1, 3, and 4. Now what is the next step? Find out A transpose A. A transpose A. So that will be equal to what it will be. Can you give me answer quickly? What will be A transpose A? What?
13,553.
Can you come up, or you can write in chat box? Come up again. 1, 3,
5,
5,
5, and 3.
5, and 3. Correct, right?
Yes, sir.
Okay. Now this A transpose A into, since you took Y on second column, here you took 1, 1, 1. Let me 1, 1, 1 in the second column. Your intercept will be the second variable. First variable will be slope, and second will be intercept. Intercept. And this should be equal to A transpose Y. Okay. So A transpose Y value, if you have, you can plug it in. So I am just assuming it is 1, 2, 3. Okay. Now you solve it, you will get slope and intercept. Okay. This will be the form of question, and this is how you will solve it. Okay. Any doubt in this now?
No, sir. No.
Sir,
Okay.
just the terminology.
So,
This entire process is clear. The feature matrix, I don't recollect. Which do they refer to as the feature matrix?
feature matrix is the independent column stacked with a dummy column 1, 1, 1, either as a first column or last column.
Okay, and what is the difference you had mentioned? If it's the first column, then
So if you are taking dummy column as the last column, then your intercept will be the last variable. If you take it as the first column, then your intercept will be the first variable.
okay. So it will be intercept and then second as slope if the dummy column is the first column.
Yeah, so that is very, very clear. Why it is so? This is because 1, 1, 1 denotes intercept. So for the first line, 0 is the variable's value and 1 is the intercept value. For the second, 2 is the variable value and 1 is the intercept value. For the third, 3 is the variable value and 1 is the intercept value. Therefore, every time intercept is at the second position.
Yeah.
Therefore, in the variable, intercept came as second position.
Yes. Okay.
If you do it opposite, intercept will be at the first position. That's it.
Yes. Thank you.
Okay. Sir. Okay. So I think we are good with week 3 then. We can move to week 4, right?
Yes, sir.
Yes, sir.
Okay. So week 4 starts with linear and polynomial regression. Again, I think feature matrix and all those things are clear. So I should repeat it, or I can leave it.
So it is somewhat the same, right?
Yeah,
It's
yes,
same thing again.
Yeah, it is the repetition of the same thing. So basically
only
what
thing
happens
is-
when you have data, it has different attributes. For example, if you want to predict, if you have a situation where you want to predict income of a person based on his age, education, and experience. So this age, education, and experience are the attributes or the columns, and this particular education and experience, when you put it into matrix, it is called feature matrix, denoted by A, and income is the target matrix, which is denoted by Y. Okay. Now, a particular record, whatever is the row, okay, for a particular person. So this 01 represents a person, 02 represents another person, and 03 represents another person. So the first row, 35, 15, 3, this together represent one person. 45, 15, 8 represents another person, and 35, 16, 5 represents another person. So they are written as x1, x2, x3. These are nothing but records or the column vectors. Then y is remain same. So for x1, the y is 100,000. For x2, the y is 150,000, and similarly for x3, the y is 200,000. Okay. Okay. Now this income hat, what I have shown over here, is nothing but some prediction based on a model. Suppose I have model which gives me prediction like this. Then what is the error with actual value? 100,000 minus 100,000, 100. So that is 100. Okay. Similarly for second, there is some error. For third, there is some error. Now, if you go on sum the squares of each error, you get sum squared error. And suppose you divide it by the number of variables, number of rows, mean squared error. This is what I have explained in this particular slide. Okay. So I think this method is clear, right? We have done this in enough of the questions.
Sir, is least square method and linear regression both are same, right? Just a different name.
Yeah, least square method and linear regression are same. You can say linear regression is based on least square. That will be more appropriate of stating.
Sir, can you
So
please
least
repeat?
square
Linear regression is?
based on least square.
Okay, okay.
So linear regression is a method, least square is a bigger term. Okay.
Sir, can you repeat what n here is?
N is the number of errors.
Sir, one doubt exactly is 100,000, 100, and 149,000 and 200,000, 100, 1,000. So that is already is given, right?
So see, this will be given. This particular column will be given.
Yeah.
This you will calculate by using your model.
Okay.
Okay. So linear regression, see what happens when you have, for instance, here I had age, education, and experience. So from this, suppose I want to find the prediction, it will be given something like this. The linear regression will look like theta naught plus x1, theta 1 plus x2, theta 2 plus x3, theta 3. So my estimate will be depending on this theta. So these are called parameters. Theta naught, theta 1, 2, theta 3. This is what you calculate to form the model. So if you calculate this theta naught, theta 1, theta 2, theta 3, you form the model. So once you have model ready, next step is to find error. So when you have model, you find error. What is the use of error? So error does nothing but find how your model is close to the actual values. So that
Sir, in this case,
error.
how are you finding the parameters? Theta 1, theta 2, theta 3.
How you are finding that parameter is my question. Tell me. So 5 minutes before we did A transpose A x hat equal to A transpose B.
Yeah.
So what was x hat? Slope and intercept.
Yes.
So slope and intercept are nothing but parameters.
Okay, so in this case, we use the same thing, just
Yes,
that.
obviously it is of the same form. If you forget this x2 theta 2 x3 theta 3, what remains? Theta naught plus x1 theta 1, which is similar to M plus C plus MX, right?
And sir,
So
in week 10, in analytical method, there is one concept called X transpose X inverse into X transpose Y. Is that the same thing again?
yes, again, it's the same thing. It's, suppose you write A transpose A X equal to A transpose B. Now you take A transpose A on the other side. So it will become inverse. Okay. Am I clear?
Yes, sir.
Yes, sir.
Okay. So
So this equation actually we are forming Ax equal to B form, right?
Yes, correct.
But suppose sir, in case the B is not belongs to the column space of A, then we have to go for this projection matrix and solve it.
Yeah, very right. Very
But
correct.
yeah, it will take long time now. First, I have to form this equation, then solving, then find no. It's not,
Yeah,
not
so
easy.
there are two parts to this question as well. First, what is your priority? You want to solve or you want to stop yourself from solving if the method is long? First thing. Second thing, computer does it for you.
No, I'm asking sir, with respect to this exam.
With respect to this exam, you have to solve it. There is
But-
no point of saying that it is a long process.
Okay.
So from week 3, what are the
So for
important
long
topics?
process, there linear regression and for week 4 or for week 3.
Sir, both actually.
So for week 3, I think least square method, projection, all these things, whichever is there in your practice and graded assignments are important.
Like most important
And
practice and graded,
one
right?
more thing, I have not seen question paper, so I should not be the person who you should ask. You may ask this in next revision session. So week 5 onwards, you people may be having some other revision session, right?
Okay, so you
Hello?
will not be taking that session, is it?
Yes.
Yeah,
Yes,
so
yes.
most probably I will not be taking that session. So wherever there is other people, Vishal and Anamika ma'am and all, you may ask over there. So because I have not seen question paper, so I'm not part of it. So I am not the right person to answer that. But from intuition, I can say linear regression, least square, all these are important. Projection, everything which is covered in practice and graded.
Excuse me, sir.
Okay. Yes.
In least square method, there was 2 parameters, slope and intercept, right?
Yes.
So we created one dummy column.
So
what if there are 3 parameters? Like how can we create more than?
So I'll show you again. So now number of records here were 3. So whatever is the number of records, you have to just go on adding that number of 1. The column is always 1 only. Number of column that you add is 1 only. So number, okay, what I'm trying to suggest is, now suppose you have like this 1 2 3 1 2 2 and 2 1 2. So this is you are saying there are 3 variables, right?
Right.
So you just want to know how many dummy features you should add.
Yes.
So for every record you have to add only one. So basically you have to add only one column.
Okay.
Sir, in this example below, age, education, and experience, we will add only one column with 3 1, right? 3 ones.
Correct. So it will become 35 15 3 1, 45 15 8 1, 35 16 5 1. Okay.
Okay, sir. I
Okay.
think you can
Next
go
thing
ahead.
is finding error. Okay. So see, finding error actual minus predicted square. Okay. So if I write it in mathematical form, it will be EI square equal to Y hat I, which is prediction minus actual whole square. So in matrix form, if I want to write, it is denoted by A theta minus Y. But since there is square, so what I am doing, I am finding dot product A dot A equal to A transpose A, which is equal to A square. So basically in place of A, you are keeping A theta minus Y. Okay. So it is nothing but dot product of A theta minus Y with respect to itself. So it is A theta minus Y transpose into A theta minus Y. Whole into half, this will give you half. This half has no physical significance. Theoretical convenience. So even if you do not use this half, your loss remains same. Okay, now this particular formula, someone asked me already. So this is nothing but the least square that we are solving. A transpose A x hat equal to A transpose B. So here instead of x hat, we have theta, and instead of B, we have Y. And this del E equal to 0, I think I have solved this on discourse in last term or last to last term. And that particular sheet is available on discourse. You may see that.
Sorry to interrupt, sir.
Uh-huh.
In that kind of question, we'll add only one dummy column, but B, like A transpose A is equals to A transpose B, right?
A transpose
A transpose A x hat A transpose B. So what will we do with that third variable?
Third variable,
Or
which
third column.
Third column. Third column in a sense?
Can you show me that?
Yeah. Example.
Yeah.
Okay, this particular example. Okay.
Not that one. Theoretical one. Yeah, age, education, and experience. So, from age and education, we can get experience. So,
No. Now the problem statement is you have to find income from age, education, and experience. So all these three are variables, and income is the target variable.
Okay.
So basically, your data set will look like this. See, what is given in the question is like this: age, education, experience, income. Okay, and it will have some values: 1, 10, 15. Okay, so a person of age 1 having experience 15 is very funny. So maybe 100. And some income 100,000. Next, age 50, education 5 and 8 and some 200,000. Okay. Similarly, 45, 6, 17 and some 350,000. Now in the question they will say find a model, a least square model to predict income based on age, experience, and education. Okay.
Okay.
So here when you are solving this part, this whole part with
dummy column
will form your A.
Okay.
Got it?
Okay. Got it. Thank you, sir.
Yeah, most welcome. Next,
So for that question, we have to take the all 3x3 with one dummy column.
yeah, correct. So your equation will become 3 cross. Sorry, your feature matrix will become 3 cross 4.
Yes. Okay.
Okay. Next thing is maximum likelihood. So maximum likelihood again is not important from exam point of view. So you can skip it. Polynomial regression is important, and numericals of polynomial regression you may check from your gradient and practice assignment. So I think questions will be of the similar form. Again, I am saying better asked in next revision session. Whoever takes it, it will be better if you ask those people. But again, polynomial regression, if you people remember, there is a simple way of solving it. It is similar to linear regression. First, you have to transform the matrix, transform the given variables like 1 x square, then 1 x2 square, 1 x3 square, then theta 1, theta 2, theta 3, and then there is variable y. Just solve it by taking inverse on the other side, you will get the answer. So there are similar questions in practice and graded assignment. You can go through it once. Okay, any doubt in this? That constant column is just to handle the general case of a linear regression. Otherwise, the line will pass through origin, fit the data as expected. Yeah, you are right, Prash. So general case of linear regression, yes, you're right. So it's just that I will maybe show you what it actually. Now suppose I have this data and I want to fit the model. If I want to fit the model, so what it should be like this: 100 for the first record. I am saying it is 100,000 equal to some. Let me call age as A. C1 star 100 plus 10 star C2 plus 15 star C3 plus C4. This is what a linear regression model looks like. So you have to find C1, C2, C3, C4. Okay. Now for the second, if you write, it will be again 200.
But we have only 3 equations, right, for 4 variables.
Yeah, correct. So therefore you go with A transpose A, X equal to A transpose AB. So this is how you, therefore this dummy columns comes. This is because of this C4. Because for C4, your multiplication factor is 1. So it is always 1. Therefore this dummy feature comes into play. Next, regularization is also not important from exam point of view. This is also not important. Eigenvalues and eigenvector is very important. So I think you people may have seen the tutorial. So eigenvalue and eigenvector, the concept is clear from that. And for the numerical part, you have to use Ax equal to lambda x. This particular, yeah.
So in last question, we have 4 equations and 3 variables. How to find the how to find the variables?
3 equation and okay. See, this particular is an example which I have taken manually, right? Don't expect it to be perfect. So in real cases, you will get 4 equations having 3 variables.
Okay, okay.
Or 5 equations having 3 variables.
3 variables, 4 variables.
Yes. So here you can solve it using X. This is a real example. This is just for your understanding.
Okay.
Yeah. Next, eigenvalue and eigenvector, you have to solve it using hello. My voice is audible, right?
Yes, sir.
Yes,
Yes.
sir.
Yeah. So if you want to find your eigen values, then you have to use ax equal to lambda x. This sorry, eigenvectors. You use this ax equal to lambda x. This is for eigenvectors. Okay, I have already written this. If you want to find eigenvalues, you use this equation. A minus lambda a equal to 0's determinant, and then ax equal to lambda x is used to find your eigenvectors. So finding eigenvalues and eigenvectors, I think you people have any problem with it? Anyone? Or it can be done? Hello?
It can be done.
It can be done.
Next is diagonalization. So for diagonalization, we have a few steps. First, the given matrix, we find its eigenvalues. Next, we find eigenvectors using the eigenvalues. Then we stack these eigenvectors as columns like this. Suppose the eigenvalues are lambda 1, lambda 2, lambda 3. Corresponding to eigenvalues, we have eigenvectors x1, x2, and x3. Then
The
we
largest eigenvalue we take first, right?
see, again, it is a convention that we use. See what happens when you decompose it, no? When you decompose it and you use this S and S inverse AS, then lambda 1 will come here. This will be corresponding to x1 that you take here. So it can be largest, smallest, whatever you take. But in general, what we do, we take lambda 1 is largest, lambda 2 second largest, lambda 3 smallest. So in general, we do that, but it is not a mathematical rule. This is just a convention again. Okay.
That means, sir, if I change this order,
that is
it
also
will-
okay.
No
Yes.
problem.
No problem. No problem mathematically. It's just that your order of eigenvalues will change.
Oh.
Okay. So this part is again, these following steps are used for diagonalization. Next, this S inverse AK, S lambda K. So if you want to find kth power of your matrix A, then you use this. So what you basically do, if you want to find a kth power of A, then you use just S will go to the other side. So it will become S lambda to the power K and then S inverse. This is how you find kth power of A. So this is the importance of this equation, nothing else. The Fibonacci sequence is again not important from exam point of view. Orthogonally diagonalizable matrices are nothing but special cases of diagonalizable matrices where your matrix is symmetric. So if your matrix is symmetric, what happens? This S that you find are orthogonally diagonalizable. That's what happens. So orthogonally diagonalizable means whatever are the columns of this A, they are they are orthogonal to each other. This is what means orthogonally diagonalizable. Okay. So what are the steps involved? First, find the eigenvalues, find eigenvectors as always. Third step is important, which is new, which is normalize your eigenvectors. So by normalizing, what I mean, whatever is the vector, suppose it is 1, 1, 1, then take 1, 1, 1 and divide it by the length of 1, 1, 1, which is 1, 1, 1 divided by root 3. Similarly, 1, 1, 2. Suppose there is a vector 1, 1, 2. Then what you will do? You will do 1, 1, 2 and then divided by 1 square plus 1 square plus 2 squares whole root, which is 1 plus 1 plus 4, 6, square root of 6. So this you do with the eigenvectors. And then all the steps remain same as your diagonalization, which was like stack the eigenvectors, then find the decomposition. Okay, so I think this much was there in week 4. Any doubt?
Repeat the last.
Repeat the
last line. You just mentioned it. Can you repeat it?
Yeah, this one. Okay, I'll write it maybe. Suppose my eigenvectors are.
Sir, so in simple diagonalization, we do not normalize the eigenvectors, right?
Yeah, correct. So suppose my eigenvectors are like this. So I will take a liberty of writing them as row, if you don't mind. So you have to write it as column 1, 2. So these are suppose my eigenvectors. Now in case of orthogonal diagonalization, what we do x1 divided by length of x1. So this is nothing but 1, 1 divided by square root of 2. Similarly for x2, what will happen? x2 divided by length of x2. That is equal to 1, 2 divided by square root of 1 square, which is 1 plus 4 plus 4. Okay, this is what I do in case of orthogonal diagonalization. Am I clear?
Yes. Yeah. Thank you.
Okay. Any other doubt? Anything? Okay, so if we have no further doubt, I think we are ready to close, right?
Yes, I think further doubts can be addressed in subsequent.
No, so for week 1 to 4, topics for week 4. Okay, eigenvalues, eigenvectors, then this orthogonalizable matrix to some extent. Fibonacci sequence will not be, regularization will not be there. Polynomial regression can be there. Maximum likelihood will not be there. Okay.
Sir, can you repeat once?
Yeah, so I was just saying for week 4, linear and polynomial regression is important. Maximum likelihood will not be, probably it will not be there. Regularization will not be there. Eigenvalue and eigenvector questions can come on that. Diagonalization and orthogonal diagonalization question can come. Fibonacci sequence, I don't think will be there.
Okay, thank you.
Yeah, but again, confirm it from your next session, whoever takes.
Yeah, sure.
Okay. And all the best for your end term exam. When it is?
So 7th.
7th, right? Okay, so you have time. All the best, all of you.
Thank you, sir.
Thank you, sir.
And do well in your exam.
Thank
I
you,
hope
sir.
this session was useful to all of you.
Yes, sir.
Thank you, sir.
Very
Yes,
much.
sir. It was.
Thank you. Thank you.
Sir,
Thanks
just
a lot.
one
So-
question.
Yeah.
In the polynomial regression, when we have less equation than the variable, then can I take the projection and solve it?
When I see, standard rule is, if you have system of equation which is solvable without using least square, then you go ahead and solve A inverse x equal to B. Sorry, x equal to A inverse B. That is how you do in mathematics, right? But if your number of equations are more than number of variables, then you go for least square. So in polynomial regression, I think combining it with least square, if such questions come, it will be really tough in exam. So they will not give such questions. I hope so. Because it will be very, very time taking.
Okay.
Yeah. Okay. Thank you. Thanks a lot, all of you again.
Sir,
All the best.
sir, just a minute, sir. Will the PDFs be uploaded anywhere, sir?
PDF, I'm not sure. I'll talk to maybe Anamika ma'am and then.
Thank you, sir.
So it will be uploaded at the same place where you get all the PDFs. I hope.
Okay.
Okay.
Okay, sir. Thank you.
Yeah. Thanks a lot. Bye, all of you. All the best again.
Thank you, sir.